All right, guys, I'm going to show you a method for converting units called dimensional analysis. It's going to look a lot more complicated than it actually is. And for those of you who have taken chemistry from Miss Lyman next door, it's going to look scarily similar to stoichiometry, but it's actually relatively simple. We're going to start off with the unit that we want to convert. We're going to use the example that we'll see tomorrow in Physics Fix 2, which is to convert 3.75 centimeters into meters. So, first thing we're going to do in this system is to create a grid that we're going to work with. All right. Our starting unit is always at the very beginning, top of our grid, and each section of the grid is going to be what we call a conversion factor. The number of conversion factors we need to use depends on how complicated the conversion is and how many different units we are actually converting. Today, or with this example, it's going to be a relatively simple conversion. First thing we're going to do, we take the unit that we're going from, and we're going to put it on either the top or bottom opposite where it is at the beginning. In this case, it's on top, so we write it in the bottom. We then write the unit that we are going to for this first step. In this example, there's only one step, so we're going straight to meters. Now, this is where it can get a little bit, we basically have some choices at this point. I'm going to show you the way I prefer first, and then we can talk about the other way after. My next step is to always ask myself which of my two units is bigger. All right. This does take a little bit of knowledge of what units are what, but in general, you will have an idea of how each unit compares to another relatively quickly, at least by the end of the first month of class. Okay. Now I look at these two units, I know that a meter is bigger than a centimeter. The larger unit I'm going to give a 1 to. This is just to keep it simple for myself. I give it a 1. I'm then going to, on the bottom, give the number of the other unit, the smaller unit, that makes up the larger unit. In this case, 100. 100 centimeters is equal to 1 meter. With a little bit of math knowledge, you'll know that 1 meter divided by 1 meter is 1. So we're taking this value and we're multiplying it by a conversion factor, which is equal to 1. So this original value is not actually changing. We are converting the unit, but the value itself is not changing. At this point, my conversion's done for this one. It's a simple conversion. I don't have a whole lot left to do. So I'm going to go ahead and take 3.75 times 1 divided by 100. I know that that gives me 0.0375. My centimeters are going to cancel out. All I'm left with are meters. And my conversion is complete. Relatively simple. Not a whole lot going on in this particular example. Now I'll go ahead and show you the way that is slightly different than what I prefer, but which will give you the exact same answer. So we start with our same value, 3.75 centimeters. We set up our grid the same way. Our units go in the same place. The only difference is now we are not going to give the larger value the 1. We're going to give the value 1 to the unit that matches our starting unit. Now, this requires a little bit more memorization from the Physics Fix 1, but I know that centimeters are 0.01 meters. The reason that this might be a little bit easier for some people to use this method is because you're much more likely to see 0.01 meters listed for 1 centimeter on data tables. So things like in the tables on Physics Fix 1, the meaning of the number for a centimeter is listed as 0.01. So if you don't want to remember, or you don't want to have to remember how many centimeters there are in a meter, then you can go ahead and use a data table that says that 1 centimeter is 0.01 meters. Either one is going to work. At this point, we're back to taking 3.75 centimeters times 0.01 divided by 1, which gives me 0.0375. Centimeters again cancels, and we're left with meters. Now, the two examples I have chosen so far have been relatively simple, just going from centimeters to meters. But what if it's a more complicated example? So something like wanting to go 1,578 hectoliters to, let's say, deciliters. All right, hectoliters, 100 liters, deciliters, 1/10 of a liter. All right, so it's a slightly more complicated conversion. The trick here is to go through your base unit. Your base unit is going to provide you a little stop along the way that just makes it a little bit easier. So, 1,578 hectoliters. Once again, I'm going to take the unit that I'm coming from and put it opposite where it started. It will now cancel. Now I'm going to put the base unit in. My base unit in this case is liters. I ask myself which one is larger, hectoliter or liters. Hectoliter literally means 100 liters. So 100 liters is more than 1 liter. So a hectoliter is larger. It gets the 1. How many liters are in a hectoliter? Like I've said, hecta means 100. So we give it a 100. All right. Now, we have canceled out our hectoliters, but that's not what we were going for. We were going for deciliters. So I need another conversion factor. This conversion factor is going to convert this unit into the one that I want to end up at. So liters is on top, new liters goes on bottom. The final unit that I'm going for, deciliters, is going to go up here on the top. Once again, I ask myself which one's larger. In this case, a liter is larger than a deciliter. How many deciliters are in a liter? There are 10. At this point, my liters cancel. I'm left with deciliters, the unit that I initially said I was going for. So I'm ready for my math. I'm going to take 1,578 times 100 times 10, divided by 1, divided by 1. That's going to give me 1,578,000, or 1,578,000 deciliters. The last example I'm going to do today involves a very complicated unit. But the system that we're going to use in order to convert it is exactly the same. It's just going to have more steps. So I'm going to change 9.8 meters per second squared into units of feet per hour squared. I know these units are going to convert because I have a distance on top divided by a squared time on the bottom. So I know I can do this conversion. So I'm going to start with my basic unit. Now, the difference here is I'm dividing by some unit. So that goes on the bottom. That second squared goes on the bottom. Do not get confused and write it up top like this. If you do this, you'll almost certainly make a mistake. always make sure you get it down on the bottom. So 9.8 meters per second squared. At this point, I have a decision to make. I can decide to convert the meters first or the seconds first. Your choice, you can do whichever one you want. I'm going to go with meters this time. Completely chosen at random. So, meters, and what am I going to? I am converting it to feet. Now, I want my meters on the bottom so that they cancel. Feet goes on the top. And this is where that knowledge of the size of different units is going to be helpful. I know that a meter is this long, which is much longer than a standard foot, which is about, that long or so. Okay? So I know that the meter is longer, so I'm going to give it a 1. Now, how many feet are in a meter? I don't know this off the top of my head. I have chosen to go for an imperial unit instead of the metric unit. To do this kind of conversion, you're going to have to look this sort of information up. You are more than welcome to do so. Just know that on a test, if you need to do this sort of conversion, you will be given the conversion, either in the question or in a data table at the end of the test, something like that. But you need to go find that information somewhere. I happen to have it pulled up on my iPad right now, and I'm going to call it 3.28 feet. There's a couple other decimals in there, but they're not big enough for me to worry about right now. Okay? So, I now have my meters taken care of. The units I am in with this conversion right here is feet per second squared, not the feet per hour squared I want. So, I need another conversion factor. I'm going to convert seconds to hours. I can do this a couple of different ways. I would recommend not trying to do the squared part and instead just putting in an extra conversion factor, because it's going to introduce more opportunity for mistakes if we try to do the squared at the same time. So what does that look like? Over here, I have seconds squared on the bottom. So in my conversion factor, I'm going to have seconds on the top. Now, at this point, I can convert from seconds straight to hours, or I can go from seconds to minutes, and then from minutes to hours. Either one will work. I'm going to go straight to hours because I happen to know off the top of my head that an hour is larger and that there are 3,600 seconds in an hour. So now, I have canceled that seconds with one of these seconds. I still have a seconds down here. All I've done is canceled the squared. So, at this point I have feet per second hour. I'm not done yet. So I need one more conversion factor. I need to get rid of this seconds. So I'm going to throw in another conversion factor that looks exactly like this one. 3,600 seconds, 1 hour. That seconds cancels with this seconds. I'm left with feet divided by hour, or feet per hour squared. At this point, I have the units where I want them to be. All I need to do is the math. So 9.8 times 3.28 times 3,600 times 3,600 divided by 1, 1, 1. So nothing to worry about on the bottom. So I'm going to do 9.8 times 3.28 times 3,600 times 3,600. That gives me 416,586,240, or 416 million feet per hour squared.